Hey everyone, welcome back to EduVibe. Today we start with the another topic of 1D kinematics, which is the velocity. So let's start with first with velocity. So we know that velocity is the vector quantity. That's why we put like small arrow like this. Velocity is the rate of change of position. When we change the position, we change the rate of the position, then the velocity will occur. The average velocity can be determined by the average velocity is equal to delta d upon delta t. Then delta d is displacement, and that delta t is the object's time, how much time it takes to make the displacement. That delta d shows that this is a change in displacement, which is final displacement minus the initial displacement, and that delta t shows that this is the final time minus initial time. And we will also get the average velocity by delta d total and divided by the t total. The units for the velocity is meter per second, as we know that velocity is equal to delta d upon delta t, which is delta d should be in meters and time should be in seconds. So we get meter per second from there. And also velocity always indicates the direction of the object traveling. Next, we have speed versus velocity. So we know that speed and the velocity are like more likely same to each other. So that's why the speed is the scalar quantity. Speed does not have the direction, they only have the magnitude. Velocity will know that it is a vector quantity and their overall displacement over total time. So what is the overall displacement which will over that the time? So here's the question about the velocity and the speed. So the question says that the car travels the 77 kilometer per hour north for 3.8 hours, and then it travels 49 kilometer per hour south for 2.6 hours. We have to determine the average speed and the average velocity. So before calculating this, we know that what is our speed. We know what is our speed or the velocity, and we know our time. For the two paths, like we have one part for north and one part for south. So we do it like that if we know that v is equal to d upon t, which is distance upon time, and if we need that d distance, and for the distance we do velocity times t, which is speed times t. So for part 1, which is not ration, this one, from here we know that the d is equal to v times t. So v is 77 kilometers per hour, time is 3.8 hours, and we get 290 kilometers, and this is north. For part 2 we know that again. For part 2 again, d is equal to v times t. V is 49 kilometer per hour and time is 2.6 hours. So we get distance of 130 kilometers south. So this is our distance in the north and this is a distance in the south. From these we calculate the average speed and average velocity. So firstly we have to find the average speed. So for average speed, we calculate V average. V also denotes the speed, but we didn't put the vector on this because the speed is a scalar quantity. Is equal to total distance upon total time. So for average speed, we have two distances, which is 290 and 130. from these two, and time we have 3.8 plus 2.6. So average speed is equal to 420 upon 6.4, which when we calculate we get 66 kilometers per hour. We need this in meter per second because we know the average speed and velocity always be meter per second because they are the standard units. To find this, so we know that 66 into 1000 divided by 3600. So for kilometer per hour to meter per second, we have to calculate like this. Multiply by 1000 upon 3600. For meter per second kilometer, we have to reverse for this. And from here, we get 18 meter per second. So this is our average speed. Now we have to find the average velocity. So for average velocity, now we have to put that factor. And we know this is equal to the total displacement upon total time. So for average velocity, now for average velocity, we know that are like 290 kilometers per hour is for the north and 130 kilometer per hour is for the south. For south, we always state the negative of this. For north, we always state positive. Because the velocity is the vector quantity, so we have to put the signs for the displacement. Like for the north, we put plus 290 and we do plus because of total displacement, and we put the minus 130 because for the vector quantity. And we divide this by 3.8 plus 2.6. So average velocity is equal to 160 upon 6.4, which is 25 kilometer per hour. And we have to be in meter per second, so we do 1000 divided by 3600, from where we get 7.0 meter per second. This is in positive, so we put not direction. So from here we get the average speed, which is 18 meter per second, and the average velocity, which is the vector, is plus 7.0 meter per second or 7.0 meter per second north. So we also know about some of the graphical analysis. For these types of question, we always get these question about the uh, solve for the velocity with this graph analysis. So for the position time graph like this is the position time graph. You know that if y-axis is position and time is in the x-axis. So for this, we have to calculate the slope for this to calculate position and to find the velocity. So slope of the best fitted line on the position time graph is the velocity. So we have like random points on the graph. When we put the best fitted line, straight line uh, between these points, passing through these points, so we get the velocity from there. When an object is moving in a uniform motion, when it's moving on a uniform motion, so we always get the constant velocity, or we can say the average velocity for the graph. On the position time graph, we could indicate by the constant slope. So always in the position time graph, we indicate as a constant slope for the velocity. So you know that, so here we have an example for this, like this image shows you example, like we have a graph and we have to find the average velocity of an object in meter per second. So how can we find this? So for this, we want that scale. We want the scale to, like we have to make the best fitted line. So like I put it still there, like these points can be passed through this. like this. We put the point which pass into 2 points, and these 2 points can be extended through the x-axis and the y-axis. For the x-axis, we have to like this, straight to that point, like this. It's approximately 20. These are the operax values, so don't be so like particular about the points. They should be like goes from there to there. Same for the second point which touch the graph. This point, this was approx 10, and this one approx 80. So from here you get some points like this point, and this point touches the graph on the axis. So for the average velocity, you have to know that the if we do total, which is change in position, like we have the 2 points on that y-axis, one is this and one is this, and when we do the suppression for both, then we get the change in position. And same for the time, we have a 2 times on the x-axis, so we do change in time. So for this, like for distance, which is position, we get this is 110 approximately, which is in center in 100 and 120. So we have 110 minus 80. From here we get 30 kilometers because this is in kilometers. And for this and this, we have delta t, which is approx 20 minus 10, and we get 10 hours because this is in hours. So now to find the average velocity, we have 30 kilometer per hour upon 10 hours, and we get 3.00 kilometer per hour, which we have to be in meter per second because they tell us that find a constant velocity in meter per second. So we have to do 1000 divided by 3600, and we get 0.83333 meter per second, which is approximately 0.83. So this is our average speed for this graph, which is 0.83 meter per second. So these are the questions you also get for the velocity position graph to calculate the velocity. So here's for this video. So I hope you understand this lesson and learning made simple with EduVibe. Learn smarter but not the harder. Please like, share and subscribe to my channel. If you have any question related to this topic, let me in the comment section. See you in the next video with the another lesson of this unit. Till then, stay connected with EduVibe.